A very good morning to you all. So I will going to continue with your exercise 8.4 and second uh, question number 4. Question number 4 onwards with its parts. So like here it is. Choose the correct options. These are the MCQ type questions given to you here. And moreover, as already I have shared with you the identities, that is sine square theta plus cos square theta is equal to 1, and then that was secant square theta minus tangent square theta is equal to 1, cosec square theta minus cos square theta is equal to 1. So these three you keep in your mind, and wherever you find useful any one of these, please go for the same. That is the application part we are doing here in this exercise 8.4. Like the first is 9 secant square, 9, that is 9 secant square a minus 9 tangent square a, 9 secant square a minus 9 tangent square a is equal to, there are 4 options given to you. Question 4, first part, and exercise 8.4 and CERD. So you just can keep a watch upon that. So 4 options, you just read very carefully all the 4. 1980, 1980. So I use this, 9 is common, I take that out. This is secant square a minus tangent square a. Now look at this, secant square theta minus tangent square theta, I said is 1. So 9 into 1 is 9. That is one of the option out of 4, and that is B. So option B is the correct option from your answer point of view. So see the advantage, how directly I can make use of this identity. So this is there, and if I am remembering this identity, so directly without solving anything, I can put the result and I can get the answer. This kind of practice, dear children, you need from the objective questions point of view, which will be the part of your examination now in term 1, especially, which is going to be conducted somewhere in the month of November by CBSE board. So please make a note of that. Then second part you see now of the same exercise. Fourth question, second sub part is, the question is 1 plus tangent theta plus secant theta. 1 plus tangent theta plus secant theta into, then this is 1 plus cot theta minus cosec theta. 1 plus cot theta minus cosec theta. As I was discussing with you during the live class, very smartly has used this identity, will be the part of your syllabus. But what's about these? You know, origin for these two is also sine and cos. So whenever I am talking about tangent, secant, cot, cosecant, I know the procedure is there to convert all these in terms of sine and cos. And by doing that, I hope all of you will be able to get the answers by applying this result. All the other previous knowledge testing part will also be checked during the solution of these. That is the difficulty we are finding with the conditional identity, and the children are always finding a bit comparatively, I am saying, difficult as per your exercise 8.1, 2 and 3. So what you will do here is, if you don't know anything, you try to come back in terms of sine and cos. So tangent can be expressed as sine theta upon cos theta, plus secant can be written as reciprocal of cos. Here also 1 plus, this is cos theta upon sine theta, reciprocal of tangent. If tangent is sine upon cos, cot will be cos upon sine, and cosecant you know is the reciprocal of sine theta. Now simplest form, that is in terms of cos and sine, I have written But what else I can do from the previous classes point of view? So I know that you did in real numbers and all, you take the LCM. So you can do that here. That is cos theta here I'm getting. So this will be cos theta plus sin theta plus 1. So, and into you are getting here again the LCM. This sin theta, so you are getting this is sin theta plus cos theta and minus 1. So now come back to your this step, especially how good you are in calculation, how good you are in algebraic identities. That is only the difficulty we are finding in this topic. So the question is definitely belonging to your high order thinking question. As you can see here, if I keep a watch upon this, see this is line, if I take this as A and this as B, so I find my numerator is there in term of A plus B. Again you see here, this is A and this is B, so this is lying in the form of A minus B. So I can see A plus B into A minus B, and that I know what is A plus B into A minus B is A square minus B square. So that you have to apply here. Cos theta plus sin theta is A square, and 1 is B, so B square, A square minus B square into, so I can write that is cos theta into sin theta, cos theta into sin theta. Now again another identity is there, A plus B whole square, that you can apply A square plus B square plus 2AB, 2 cos theta sin theta minus 1, and whole upon that is cos theta sin theta. Now what's about this? That is the identity here, cos square theta plus sin square theta is equal to 1. So this is 1, this is minus 1, I can cancel it up directly. Then I'm left with 2 cos theta sin theta upon cos theta sin theta. So you cancel it up also, you are left with 2, which is one of the option out of 4, and that option is lying at C. So C is the correct option for your this answer. Option C is the correct option. So how to solve that, I'm trying to make you people understand here. So you see the question started with tangent and secant or cotangent and cosecant, but is finishing at what? Sin square theta plus cos square theta, which is the part of your syllabus. So all these questions you need to practice, dear children. Do not think that the application directly will be given to you based upon sin square theta plus cos square theta. That can be asked in terms of cosecant as well as secant or tangent or cotangent. So please make a note of that. Let us see the third part. Simply you need to do the practices in writing. That is very important from this topic point of view as newly added to your knowledge, but I will not think is a difficult one. So third part is secant A plus tangent A. Secant A plus tangent A into, then it is 1 minus sin A. 1 minus sin A. Again, let us begin with same thing. Secant A I can express as 1 upon cos A. Tangent A again sin A upon cos A. And then this is 1 minus sin A. So here again you see this is the LCM here if I take is cos A. And then in numerator I will left with 1 plus sin A. And here it is 1 minus sin A. Again that is A plus B into A minus B. That I know again is A square minus B square. 1 square minus sin A square. So upon cos A. So I will be getting 1 minus sine square A upon cos A. And from here you can see now, if cos square theta plus sine square theta is 1, so 1 minus sine square theta, so 1 minus sine square A is equal to cos square A. So that you can put there, cos square A upon cos A, and if you see cos square A can be expressed as cos A into cos A upon cos A. So I can cancel this. I will be left with cos A, which is one of the option given in your answer, and that option is at D. So option D is the correct option for this particular part of question number 4. So see how I am proceeding. I am going back in terms of sine and cos, and is the best way, because I know I have to reach somewhere here. Once I am clear with this, then algebra is also very important. Identification of those identities, what already I have finished in my previous classes. You need to apply that nicely, and then see the answer automatically is coming over there. So that's all about the third part. Now let us go for the fourth part of this. So fourth is, here it is, like 1 plus tangent square A upon 1 plus cot square A. 1 plus tangent square A upon 1 plus cot square A. If you see, this result implies, if I shift this tangent square A to this side, I will be getting 1 plus tangent square A is equal to secant square A. And from here also similarly 1 plus cot square A. If you remember the identity, then you can use this result directly that I am trying to make you understand here. And then this will be cosec square A. So means directly I can write this is secant square A and this is cosec square A. Cosec square A. And secant I know is the reciprocal of 1 upon cos square A upon 1 upon sine square A. So finally you will be reaching where? 1 upon cos square A into sine square A upon 1. So this is sine square A upon cos square A. Sine square A upon cos square A, which is equal to tangent square A. So tangent square A is one of the option given to you, and that is at D. So option D is the correct option for this. Suppose you don't remember this identity, then again you go back to that sine upon cos and cos upon sine, take the LCM and do the calculations. You will be back to this result, 1 upon cos square A upon 1 upon sine square A, by making the use of identity sine square theta plus cos square theta is equal to 1. So no issues about that. You can work out within that procedure also by taking tangent as sine upon cos and cot as cos upon sine. So see, you will be reaching here in that way also. So that's all about your fourth part, or question number 4 is over. Now question number 5. Question number 5, 2-3 parts I will be taking within this lecture, and the remaining I would like to finish in the next lecture, so that you can spend ample time in understanding these through this video lecture. So suppose I am taking the first part of this question number 5. Prove the following identities where the angles involved are acute angles for which the expressions are defined. So all these thetas wherever are given are the acute ones, and conditional identities are these. In question number 5, whatever the subparts we are taking, all these are the conditional identities. So you need to understand what do you mean by the conditional identity. Means you are not allowed to shift from right to left or left to right in the very first step of your answer. Whatever is given in the left hand side or in the right hand side, directly you can start either with the left hand side, so you'll be reaching at the right hand side, or with the right hand side, so you'll be reaching at the left hand side. In case suppose it is not going to happen, you need to simplify the left hand side as much as per your knowledge in these identities, and once you reach there, you give that number 1. Then you start with the right hand side and simplify that also. Once you have simplified, give that number 2, and then see 1 and 2 equations are there. Name those 2 equations, compare those 2 equations, you will be finding the left hand side is equal to right hand side. So you need to prepare in that way. I will be taking the examples back to back from your understanding point of view. Let us take the first, like the sec theta minus cot theta whole square. This is cosec theta minus cot theta whole square is equal to 1 minus cos theta upon 1 plus cos theta. So I will just share the answer in both ways. You can start with the left hand side or you can start with the right hand side. But most of the times when I put this question, what shall I do here with the answer of this particular question? So mostly we will be taking the left hand side there. Why the left hand side? Because the possibilities to solve this are there. This I am finding mostly in the simplified form, that is in term of cos. Numerator is 1 minus cos, denominator is 1 plus cos. So here if I take the left hand side, so I will write in my answer, take left hand side. As I said, if I will start with the left hand side, I will be reaching at the right hand side. So take left hand side, that is equal to what? Cosec theta minus cot theta whole square. So here if I solve this, cosec I can express in terms of sine and cot in terms of cos upon sine whole square. So I did not expand that in terms of a minus b whole square, where I need not to go for that squares like cosec square theta, cot square theta and all. So more complications will be there. First of all, better to take the reciprocal of cosec in terms of sine and cot also in terms of cos and sine. Now let us talk about the LCM sine theta, and here it will be 1 minus cos theta. Very comfortably I can do that. And I know in right hand side you need to keep a watch simultaneously upon the right hand side also. That definitely is going to be a great help for you to get the solution. So I need this, I am getting this in my picture. So the best way is to express it somewhere in terms of 1 minus cos theta into 1 minus cos theta, and upon find sin square theta, sin theta into sin theta will give you sin square theta. So then if I proceed further with the left hand side only, you see this will be equal to what? 1 minus cos theta into 1 minus cos theta upon, this is sin square theta, I can write as 1 minus cos square theta, 1 minus cos square theta, because sin square theta plus cos square theta is equal to 1. So when I will keep sin square theta this side only, shift this cos square to this side, it will become 1 minus cos square theta. So here it is 1 minus cos theta into 1 minus cos theta. So a square minus b square is what? A minus b into a plus b. A minus b into a plus b. So you just can cancel it up, 1 minus cos with 1 minus cos. What we are left with? 1 minus cos theta upon 1 plus cos theta. That is your right hand side. So I started with left hand side and I am finishing at right hand side. So that is the conditional identity in trigonometry. So conditional means left will always be equal to right, or right will always be equal to left. That's your choice, which side you will like to start with. Number 1. Number 2, suppose I would give preference to this right hand side. So you should have that option available with you. See how can you start this answer? Because here also in left hand side I was finding it possible to write in terms of cosec and cosec in terms of sine and cot also in terms of cos and sine. So here this is the question. If you take right hand side, suppose I am taking the right hand side, I am giving another option to write the answer. And to prove that, why do we call these type of questions as the conditional identities? That is only the purpose to share the solution in both ways. To start with the right hand side as well as with the left hand side. So previously I started with the left hand side and I reached at the right hand side. Now I am starting with the right hand side and I will reach at the left hand side. How? Look at this. If this is the right hand side, so now you should have that knowledge. How I can go for this? Because here it is already in the most simplified form. By means of trigonometry or trigonometric identities, nothing is possible to do with this. But yes, with the help of algebra and algebraic identities, I can think to start with this side also. How? Because you know, you did rationalization somewhere. The rationalizing factor of 1 plus cos you will be getting is 1 minus cos. Now this will be 1 minus cos. Do that. And now because you need this in terms of whole square, come back. Now this is there, 1 minus cos theta whole square upon 1 square minus cos square theta. So finally I am getting a minus b whole square. A square plus b square minus 2ab. Do that. And 1 minus cos square theta. 1 minus 1 square is 1, cos theta whole square is cos square theta. Now you know that is equal to 1 plus cos square theta minus 2 cos theta and whole upon 1 minus cos square as I told you is sin square theta. So you write that. And now I want to go back to cosec and to cot. So I know if I will be putting 1 upon sine, that is equal to cosec. If I will be taking cos upon sine, that will be equal to cot. As I said in the previous solution, when I was taking the left hand side to get the right hand side, I need to keep a watch upon when I am working with the left hand side, I have to see the right hand side. So that I did not prefer to go for the expansion of the square a minus b whole square. Here I am expanding. Why? Because I need that. I need that square somewhere here in the left hand side. So I am expanding. Now I need cosec, I need cot. So from here, because that skill out of the box thinking I have to apply. I am finding 1 upon sine and that will give me an idea to go back to this cosec as well as cos upon sine. So what I do here is I take this 1 upon sine square theta plus individually cos square theta upon sine square theta, and then this is minus 2 cos theta upon sin square theta means sin theta into sin theta. 2 times you can write sin theta into sin theta. Now look at this. 1 upon sin square theta is cosec square theta plus cos upon sine is cot square theta. A square plus b square minus already is there. 2ab. So 1 upon sine. 2 upon sine means 2 upon sine means 2 cosec theta into one more thing is left there, that is cos upon sine, that is cot theta. That is cot theta. So 1 upon sine square cosec square. Cos square upon sine square cot square. 2 upon sine 2 cosec into cos upon sine, that is cot. So a square plus b square minus 2ab. So that is a is cosec theta and b is cot theta. So I will be getting a minus b whole square, that is your left hand side. So in this case I started with right hand side and I reached at left hand side. So that was the point I was sharing with you. Why do we call these type of questions as the conditional identities? Left will always be equal to right. So you must start with the left hand side, you will be reaching at the right hand side. You must start with the right hand side, you will be reaching at the left hand side. So that is up to you. So this is the first part. I solved for your reference in both the ways. I started in one part with left hand side, reached at right, and started with the right, reached at left. So let us take one or two more parts there from today's lecture point of view. Now the second part you can see here is, that is cos A upon 1 plus sin A. Cos A upon 1 plus sin A, and then it is plus 1 upon sin A upon cos A, 1 plus sin A upon cos A, and is equal to 2 secant A, is equal to 2 secant A. So again, suppose now this is 2 secant A means 2 upon cos A. You all are clear with that. So what to do with the right hand side? Nothing we can do. So simply I start with the left hand side, give preference to this. So you have to write that left hand side, and here I have to take the LCM in left hand side. I will be getting cos A into 1 plus sin A. First of all, you will write as it is the left hand side I am starting with. Then 1 plus sin A into 1 plus sin A will go off. Cos A into cos A will make it cos square A. Plus again cos A will go. So this will become 1 plus sin A whole square. 1 plus sin A whole square. Now you can expand this. So this will be cos square A plus 1 plus sin square A plus 2 into 1 into sin A means 2 sin A, and whole upon, that is cos A into 1 plus sin A. So cos square A plus sin square A will give you 1 plus this is 1 here plus 2 sin A, and upon cos A into 1 plus sin A. 1 plus 1 is 2, 2 plus 2 sin A, and then this is cos A into 1 plus sin A. 2 I can take common here. So inside the bracket I will left with 1 plus sin A upon cos A into 1 plus sin A. So here again you can cancel that up. 1 plus sin A with 1 plus sin A. You are left with 2 upon cos A, which is equal to 2 sec A, and that is your right hand side. So I started with left hand side and I am finishing at right hand side. So this will be the answer for your second part. So how I am proceeding, wherever already the terms are lying in their most simplified form, so I need to apply the knowledge of integers or the algebra, how to take the LCM and how to do the further calculations. And then identities automatically are becoming the part of your solution somewhere. Keep on applying as I applied here. Cos square theta plus sin square theta is 1 already is there, and then automatically we will be reaching towards the target at the end of your answer. So one more I will take, that is the third part, and then we will wind up this for today. Remaining we will be taking tomorrow. So third part is there, that is tangent theta upon 1 minus cot theta. Tangent theta upon 1 minus cot theta. Then it is plus cot theta upon 1 minus tangent theta. Cot theta upon 1 minus tangent theta is equal to 1 plus sec theta plus sec theta. 1 plus sec theta plus sec theta. Again, suppose I am giving preference to the left hand side because more options are available with me from the solution of left hand side point of view. So I take left hand side here, I write tangent theta upon 1 minus cot theta plus cot theta upon 1 minus tangent theta. As I told, if nothing is known to you, you start converting in terms of sin theta and cos theta. So 1 minus cos theta upon sin theta. Then here it is cos theta upon sin theta upon 1 minus sin theta upon cos theta. Now here this is sin theta upon cos theta upon, if I take the LCM here, it will be sin theta for this and it will become sin theta minus cos theta like this. Then here it is plus, then I will take a cos theta upon sin theta and this is upon, again now we take the LCM here, it will be cos theta and you will be getting here cos theta minus sin theta. Now please pay attention here. See, here I am getting sin minus cos and here I am getting cos minus sin. Suppose I am going to solve this like further, if you take the step now, this is sin theta upon cos theta into, you will take the reciprocal now, like sin theta upon what? Sin theta minus cos theta, sin theta minus cos theta. Done. Then this is plus, similarly here it will be cos theta, there it is cos theta into cos theta upon, if you see, that will become sin theta into what? Cos theta minus sin theta, cos theta minus sin theta. Now you look at this, one more trick I am going to play over here. How? This is sin minus cos, this is cos minus sin. If directly I will take the LCM here, then it will be cos into sin minus cos into cos minus sin. Better you just try to solve this here in one more step. Either you make this cos minus sin or make this sin minus cos. Suppose I am taking this in terms of sin minus cos, so what should be done over there? So the sin into sin will make it sin square theta upon cos theta into sin theta minus cos theta. So plus cos into cos will make it cos square theta upon. So this is, I am taking minus outside, sin theta, so that I can write, once I have taken the minus out, means I have to divide the terms inside the bracket with the negative sign. So cos will become minus and sin will become plus. So sin theta minus cos theta. Just to make this in terms of this sin minus cos, so that will be more convenient to take the LCM and from the further calculations point of view. So if I take that, so now you know LCM will be cos theta into sin theta, cos theta into sin theta, into sin minus cos, here also sin minus cos. So sin theta minus cos theta. Now look at this, cos theta into sin minus cos will go off, cos, sin minus cos, I will be left with sin. So sin into sin square theta will give you what? Sin cube theta. And plus divided by minus is always minus. Plus divided by minus is always minus. So now sin into sin minus cos, when you divide by this, so sin into sin minus cos will go off, you are left with cos only. So cos into cos square theta will give you cos cube theta. So now again the new identity is coming into existence over here in the step specially. So that is a cube minus b cube. So you remember a cube minus b cube is equal to a minus b into a square plus ab plus b square. Please remember that, otherwise you will be again in trouble here. So that is the extra knowledge, out of the box thinking, what we call, you need to apply over here. And here I have to write a minus b means sin theta minus cos theta, sin theta minus cos theta into a square. A square means sin square theta and plus AB means sin theta cos theta plus B square means cos square theta. Cos square theta. So AQ minus BQ I have solved here, and here it will be cos theta sin theta into sin theta minus cos theta. So this directly I can cancel sin theta minus cos theta with sin theta minus cos theta. Now you look at this. Sin square theta plus cos square theta, this plus this will give you 1 plus sin theta cos theta. This is sin theta cos theta upon what? Cos theta sin theta. So once you can write this is finally what? 1 upon cos theta and sin theta plus sin theta upon cos theta, sin theta cos theta upon sin theta cos theta. So 1 upon cos theta sin theta individually now. This upon this plus this upon this. So 1 upon cos will give you what? Secant theta cosecant theta. The reciprocal of cos is secant theta. Reciprocal of sin is cosecant theta plus sin theta cos theta upon sin theta cos theta will go off, and 1 upon 1 is 1. So that you can check is your right hand side here. Here you can see. So this is equal to your right hand side. So I started with left hand side, proceeding in this way, stepwise, and finally I reach here and here, and then that is the right hand side I am getting. So you see how much trigonometry and how much algebra is required from the understanding as well as from the application point of view. So these are the third part of question 5 of exercise 8.4 I have solved in today's lecture. The remaining I would like to take in tomorrow's lecture. So you just can go through these solutions. Please revise also. Wherever you are finding the difficulties, you let me know. You are most welcome during the live classes to clarify your doubts. Thank you. Have a nice time. That's all from my side.